Hey everyone, this is assignment 45B from chapter 3. Motorcyclist is traveling along straight east-west road 55 feet from her house. Below you are given a graph of her velocity, so the velocity function, so it's v, as a function of time, positive. So whenever velocity is positive, she's traveling to the east. When velocities are negative, she's traveling to the west. Estimate the velocity and the acceleration after 10 seconds. Well, that looks like a v of 10 is approximately 25 feet per second. How did I know that? Well, this is a graph of velocity, and I'm looking for a velocity at time equal to 10. So I look over at 10, I see the y value there is 25. But I'm also supposed to find the acceleration. Now the acceleration equals the slope on the velocity graph. So they're wanting me to approximate the slope here. And I find it convenient to use this point and this point. So this is going to be approximately equal to, because I don't have an equation to take the derivative of, this is going to be approximately equal to 20 minus 25 over 12. That's interesting that that's 4. 2, 4, 6, 8, 10. Minus 10. And that's going to be negative 5 over 2. And the units here will be feet per second on top and seconds on the bottom. So feet per second per second. Okay, B. Estimate the average acceleration on the first 10 seconds. Well, remember, if I'm looking for average acceleration, the setup is going to be not A of 10 minus A of 0, but V of 10 minus V of 0 over 10 minus 0. So V of 10 is the y value of 10, that's 25. V of 0 looks to be 0 over 10, 25 over 10, or 5 halves. And this is average acceleration, and so we want feet per second for average acceleration. Well, isn't that interesting? The average acceleration on 0 to 10 is a positive number, but acceleration at time equal to 10 is a negative number. So that makes sense to me, because as I'm going from here to here, I see a positive slope. But if I'm just checking here at 10, I see a negative slope. Okay. Estimate the times when her speed is greatest. Well, speed, remember, is the absolute value of velocity. So here's my velocity graph, and speed would then look like 1, 2, 3, 4, 5. So let's go up 1, 2, 3, 4, 5. And let's do that. And then we're going to come across to this point. Is it there? Yes, it's there. And then we're going to come back down here. So now I'm looking at speed. Okay, the green graph is speed. And what does it say? Estimate the times when speed is greatest. Well, this is not as high as that, so I'm going to say at t equals 6 seconds, speed is greatest. Times when acceleration is greatest. Well, so acceleration is represented by the slope on this graph. That looks pretty steep here. But does it look even steeper over here? I wonder if we could approximate. Okay, so here we're going up 1, 2, 3, 4, 5. So that's up 25, and we went over 2. Now what about the slope over here? Well, from here to here is 2. And so I've got 15 minus 0 over 15 is the y value, minus 0 is the y value, over 2 minus 0. So you get 15 over 2. Well, I think 25 over 2 is steeper than 15 over 2. So I'm going to say that acceleration is the greatest on 24 to 26 seconds. Does it ask what that acceleration is? Times when her acceleration is greatest. No. For what times is acceleration positive? Well, acceleration is greater than 0 when the slopes of v are greater than 0. Not on speed, but on the original blank graph. So here I have positive slope from a is greater than 0 on 0 to 8, okay, 2, 4, 6, 0 to 6. And do we have any other times when acceleration is positive? Sure, because the slope over here is positive. So union 54 to 2, 54, 56, 58, 60. Okay. Acceleration equals 0. Well, I have a 0 slope here. I don't see a 0 slope anywhere else. So at t equals 6 seconds. And then finally, when is acceleration negative? So we're looking for places where we have a negative slope on velocity. And so we could say that a is less than 0 on 6 to 26. Okay. Find the motorcycle's acceleration at t equal to 26. Okay, that's there. I want to know the slope there. Well, I can't find it. Can't be determined because the limit as t approaches 26 from the positive of f prime doesn't equal the limit as x approaches 26 from the negative on f prime. Explain what the motorcycle is doing from 26 to 54. So a lot of students want to say from 26 to 54 the motorcycle is not moving. However, this is a velocity graph, and when velocity is negative, they're traveling to the west, and so I would say they are traveling west on 26 to 54 seconds at a constant rate of negative 25 feet per second. Is it feet per second? Feet, yeah, feet per second. Okay, seems very slow. Does it? 25 feet per second? Oh, no, that's a lot of stuff. All right, and then G, if the graph above represents position, what would the motorcycle be doing? Well, this is position now. These are just feet. And so the motorcycle is actually stopped if this is a position graph. How did I know that? Well, I knew that because the position isn't changing. This is a position graph. Position is negative 25, negative 25, negative 25. It's negative 25 on that interval. The position doesn't change because, well, because it's always negative 25. The motorcycle is not moving. if this is position. Okay. If the graph given is position. All right, now the back of that worksheet has a second problem. Helicopter flies along a north-south straight line directly over a radar site. Throughout the flight, its velocity, this is velocity, is recorded towards the north, is positive, towards the south is negative. Well, all of this graph is above the t-axis. So velocity is always positive, and that means that velocity, the helicopter is always traveling west. Now, if this had been a position function, I have negative slopes here, so traveling to the left, and positive slopes here, traveling to the right. I have negative slopes here, traveling to the left. So if this were a position, then the object would change directions at about 4, at about 12, 15, the object changes directions. But this is in fact velocity. Velocity never goes negative, it's always positive, so the helicopter is always traveling to the west and it never changes direction. Does the helicopter change its velocity during? Sure, look, this is all about changing velocity. When is it flying fastest? T for 15 seconds, and that appears to be, I can't read these numbers, 10, 8, 6, 7. Can you read those numbers? I think I need to remake this graph. So no parenthetical. When is the object, the helicopter flying slowest? And I said that was at t equals 4 seconds. Does the helicopter change acceleration? Yes, it does. This is a graph of velocity. Acceleration is represented by the slope on the velocity curve. So do we change acceleration? Sure do. Here we have negative slopes, here we have positive slopes, here we have negative slopes. So yes, the helicopter changes direction because the slopes on via t are always changing. Okay, then they said, if so, approximate when acceleration the most. Well, that's the most steeply positive slope, and that seems to happen most positive, accelerating most at t equal 15 seconds. And that's that. Does the helicopter ever decelerate? Sure. On 0 to 4, union 15 to 35. Approximately when is it decelerating the most? Decelerating the most. That's when we have our most negative slope, which is more negative. I think that one. So I'm going to say about here, which I'm going to go with something like it's decelerating most at t equals 17. If you said 18, that would be fine with me. And we don't need to say what the acceleration is. All right, well, I hope this was helpful. I hope that you're getting comfortable with this material. If you're not, you couldn't do that worksheet in 15 minutes. You might need to practice this stuff more before we have our test.